Hi, my name is Take Rasvat, and I am going to present my assignment on intelligent information retrieval. The assignment consists of two parts. The part is to create a vertical search engine, which is similar to Google Scholar, but where we can search the publications by the School of Economics, Finance, and Accounting of Coventry University. And the second task is to create a document classification system where we have gathered the data from BBC RSS newsfeed and then trained the models so that and created an interface where user can query text text and classify the document on for three different categories: business, politics, and health. So first, I am going to demonstrate my first task. So project directory is CU publication search, and there are two directories, backend and frontend. First, let's run the backend. So to run the backend is built with fast API. So we need to run the command to start the fast API app. So I'm running the backend, and it will crawl the data first, and then it will build the index for those searches. Since I have already done it, it does not take that much of time. And while crawling the data, first it goes to this department page, and since we need to scrape the data of all the department members, so the crawler goes to the profile page, and then it goes to and then the research output tab, where all the research by the author are listed, and if any profile contains multiple research outputs in which the pagination is present, then it will click on the pagination link and go to the next page and gather all the data. Uh, after that, it goes to the individual publication page, from where it gathers the information about all the authors and abstract and the publication title and all the related data that's needed. After crawling the data, it creates index for all the crawled documents. Data is stored at inside the data folder in JSON format in the publication start. To run the front end, we can run the front end by running the npm command, since the front end is built with React.js and the Tailwind CSS. So I'm going to the front end and then running the command. The home page of the search engine, where we can search any publication, authors, or search the publications by any keyword. Here it lists the total publications and the total authors from the Department of Economics, Finance, and official site. There are total 7 profiles, but we have 6 authors because I think one of them has not any publication yet. And it also displays the total authors. It means all the authors present in all these documented source. And so let's search and title and see what we get. So for example, if I go to the profile, and for example if I go to the Lynn's profile, here are total of 7 research output. For example, I'm going to search this one. First, I'll search it on Google Scholar. So I've already searched it once. Here it is. It's by Len Lu and coming at the top. And if I search the same publication in our search engine, it will show the result, and it will show also the match percentage and the date, published date, publication title. It will redirect to the original publication, and if I click on the author link, it will redirect to the author profile. So in a query search, first we do pre-processing tasks like lowercase and stemming, lemmatization, search query, wait with the document, and then based on the cosine similarity ranking algorithm, it displays the post which matches with the current search query. And this is all about our search engine. Okay, the second task is document classification system, for which we have crawled the data from BBC News RSS feeds for politics, business and health. Then we have collected the data and trained the model, and on the basis of the trained model, it classifies our input text. And let's see it in the demo. I have used Flask for the front end, and we have used two machine learning models, mathematic, and we have used two machine learning models, naive Bayes and logistic regression, for model training and accuracy measure. I am running classifier file, and first it will crawl all the document from BBC RSS newsfeed as mentioned here in the code. Let me show it. So here it collects the data from these 3 URLs, and after crawling the data, it cleans the text, and then it pre-process text using NLTP, like removing step words, using stemming. We have factorized the text, and then we have trained the model. We have used 80% of our data to train the model, then tested the model with remaining 20%. So I think the data is scrolled over here. It's still crawling. It takes some time to crawl the data, so I'm forwarding the video over here. Okay, the crawling is done. We have crawled 40 document per category for business, politics and health, and total in 120 documents, and we have 80% of document used for training the model and 20% for testing. So here we are training the model, and we have got the accuracy over here, accuracy, precision, recall, and F1 scores over here. Then we have also created confusion matrix, and we have also plotted it, and then we have some text cases with different categories. So the model training is done, and I'm going to test it in the front end by entering some source documents. Sure, I want to open the Flask app. Okay, here is my document classification system. Here we can directly paste or type any news article, headline or text, so that we can classify it, or we can directly, for some quick test, we can just click on the button over here, and it will add some dummy content over here, and then we can. So if I click on it, it classifies the document in 2 categories. So if I click on it, it classifies the document using 2 different machine learning models. They are naive Bayes and logistic regression. Let me try it with some tests from BBC News articles. I have some links over here. Okay, here is the link from BBC News RSS from which I have. So if I paste the text and just hit the classify document button, it classifies the current text as business, and which is right. For the neighbors, it shows the confidence score of 49%, and logistic regression shows the confidence score of 40%, 40.6% for this text. Let me do one more query. For example, there is one more BBC article. I have saved the link over here. Let me open the link first. Here is the link by BBC News. So I've just copied the text over here. I'm pasting it over here and then classify it, and it classify it as politics, and which is right, and the confidence score is 42.6% for neighbors and 37.4% for logistic regression. And this shows neighbors algorithm is more suitable in our case. This is all about both assignment tasks. Thank you.